This section is 2.4. We're only covering a couple of sections in the early part of 2.4 of chapter 2, so 2.1 and 2.4, then we're going to come back and do 2.3 and 2.6 and 2.8 together. So this information is about solving equations, but the problems are going to be word problems. And so we have to go over some things of how do we translate the words into numbers. If you've got an equation, most of you can solve the equation, but here's where we have to use our words and make sure that we can understand the meaning of the words that are in the problem. So all application problems are going to involve translating the word phrases and the sentences into number statements and equations. Once you've got the equation, then you can work it pretty much. Application problems use words that direct us into math operations. So when we read the word problem, we have to understand, okay, what are words that are going to tell us to add? So I've listed a few here. And is to add, added to, increased by, greater than, plus, obviously, more than, or if they tell us that we want the sum. Now, by definition, the sum is an answer to an addition problem. Okay? So we're going to, if it tells us you want to get the sum, then that means there's going to be some sort of addition problem. Likewise, subtract, words that would tell us that your operation you're going to use in the problem is subtract would be decreased, subtracted from, and I put a little star there, and there's a special note right here that you need to know. And less than, that's also pertains to this note. Diminished by, minus, difference between, and even if you just use the word difference, okay? Difference is the answer to a subtraction problem. So if it says find the difference between two numbers, that means you're going to subtract those two numbers to see how far apart they are. Okay, answer to a subtraction problem. Now, here's the note that I wrote with the stars on it. If the problem says subtracted from or less than, something always has to exist before you can take something away from it. So if they tell you two numbers, and we're going to see down here in the notes, that means you've got to kind of flip the problem around in the way that it's from the way that it's worded. If it's multiply, words that tell us to multiply are product, and the product is the answer to a multiplication problem. Okay? Answer to multiply. Of is a multiply word. Times is a multiply word. Now, twice and double and triple words are designated. So twice means you're going to multiply it by 2. Triple means you're going to multiply by 3. And double obviously means you're going to multiply by 2. So if something is twice something, then it's going to be 2 times whatever that is. Divided by, the word for a divide problem, if it says that it's a quotient, it's the answer to a divide problem. Answer to division. So those are automatic words. Sum means add. Difference means subtract. Product means multiply. Quotient means divide. Those are exact interpretations telling you exactly what you're going to have to do. These other words are just English language words. Equals. Words that mean equal would be is, are, will be, results in, is the same as, yields. There will be some other words that you come up with. So now when we talk about what we're going to use for variables, so variables are the letters that we use to stand for some unknown value. Now, when you choose a variable, sometimes the letter that you choose can better help you answer the question that the problem's asking you to solve and to find. So most of the time, if we think X, Y's, N's, or Z's, they don't usually have any words that are associated with them. But a B if you use a B for a word, that might be the amount of money that, say, Bob has. So the B would be connected to a special name of something. A D might represent the number of dimes that a person might have in a bank. W most often talks about measurement problems. So W would be related to width. So we would use the letters that if the question at the bottom of the problem says find the width, then we would use a W in the problem, so when we get to the end and it says W equals, we know what it refers back to. If we just use a generic X or a generic Y and we get X equals, well, sometimes we don't know what that letter is standing for. And so if you'll use a kind of a code word as you choose your variable to help you with the word that you're working with, it usually helps. So when you use letters that are connected to the word, you know that when the question asks for the width of a rectangle and you get the answer W equals 13, it tells you that you have found at least part of what you need to know. After you find the width, they might ask you to find the length, but you know if you've got W, that's going to be the answer for width. Okay, so here, when we start to translate, we have to use these words up here to change from the words to the symbol. So this says the sum. Okay, so I know based on this information up here, sum is going to have to be an addition problem. So I'm going to have to take twice of a number. Well, here's where you get to choose. When we're just choosing a generic number, X and Y and N work perfectly fine. So I'm going to say twice a number. Well, twice is an automatic multiplier. So twice would mean multiply it by 2. So whatever my variable chooses to be, let's say I'm going to let that number be represented with X, I need twice X, then that's going to be 2X. And then it says and 5. Well, if my sum says add, that means I'm going to add these two together. So the mathematical expression that represents this statement is 2X plus 5. Twice a number. You don't put anything in between it. You just stick the coefficient and the variable right next to each other, and that always indicates multiplication. So over here, we want the product. Well, product up here in our information says it's a multiplier. So we're going to get the product, which means multiply 7 and some number. So you choose a variable. Maybe you want to choose n this time. So it would be 7n. And you don't write an X between it, you don't put a dot between it, and you don't need parentheses. Okay, now here's one of those with a star problem for subtraction. 4 less than a number. Okay, less than is a subtract term. Okay, it's up here. Less than is a subtract term. But 4 is not being subtracted. N is not being subtracted from 4, but 4 is got to be subtracted from n. So even though 4 is written first in the problem, when you write your statement, your problem would have to be n minus 4. Because now 4 is being subtracted from some number that we don't know. So you have to be careful when you use the words less than or subtracted from, because that means these two would have to switch places and this goes in the back. Okay, 3 more than half a number. Okay, well, half is a designated divide by 2. So I'm going to have to take my number and divide it by 2. So I'm going to have some variable. Let's use X this time. So I'm going to have X and divide it by 2. And then I'm going to get more, so more gets bigger. So then I'm just going to add 3. More is an add number. Here I have 3 more than twice the width. Okay, so twice the width. Here I'm going to use W because I'm talking about width. Twice the width would be 2W, and then I'm going to get bigger by adding 3 more to it. So 2W plus 3. Now, this problem is a little bit different because it says 5 times the difference. Well, the difference is a subtraction problem. So I have to do this first. Now, in PEMDAS, the very first thing we have is a P, which is parentheses. So when we see it written in this terms, it means this is going to have the parentheses on it. So I need the difference, which tells me subtract a number and 6. So I need to write x minus 6, and that has to be done first because that's what parentheses says. Do me first. And then now I can go back and do times 5, which is multiply it times 5. So when we do that, we're going to put the 5 on the front of it. So this expression would be translated to be 5 and then parentheses. So you're going to multiply times this difference. So it has to have parentheses on it. Otherwise, you'd only be multiplying the 5 times the x, and the 6 would be left out. Okay, of indicates multiplication. So I want 3/8, so that's a fraction. 3/8 of is times, and I'll use x here, so it just becomes 3/8 x. Over here, 2/3 of is times, so I'm going to multiply the fraction 2/3 times some number. So I'm going to have 2/3 x, and I'm going to decrease it, means get smaller, by 6. So there's your translations. So there'll be some of these problems on your homework where all you have to do is just translate the words and put them into numerical expressions. Then you're going to also have to solve. I believe on this homework assignment there's only 6 problems, but it's important because these problems kind of make or break some of the grades on tests. So you've got to know how to do word problems. And there will be word problems that are just like these examples that are on here. Now, on a test, because your test is face-to-face, my expectations are that you do some of these things. And number 1, number 2, number 3, and number 4 have to be shown on your page. Obviously, read the problem is your own thing. Then you have to choose an appropriate variable to represent what the problem is telling you to find. And you have to write a let statement that tells me what the variable stands for. Then you're going to translate the word phrases, and you're going to get a number statement that looks similar to these. Then you're going to solve the equation and then label the answer. If it has to do with measurements, then you need to label it. Or if it's an item that it describes, like you're supposed to find how many hamburgers, then you say 6 hamburgers, 3 French fries. Whatever the problem is, you don't just give me numbers, but you give some sort of explanation that tells what this answer represents. The most important thing is that you check your answer for reasonability, because sometimes a problem cannot come up with a fractional value. If you were working a problem that asked you to find how many people were involved in something, then you should get whole number answers. If you were asked to find like how many pecan pies, then the answer would have to be in whole numbers. Sometimes you're working on something that can't be negative, so you can't get a negative measurement. If you work on something that tells you to find dimensions, you're not going to get a negative number because you can't get a negative number with measurements. So check for reasonability, and also take a look and see, did I use my signs correctly? So check for your math work, make sure it's correct. And then in some cases, you're asked to write a statement that explains what you found out. So basically, you would take your answer and you would write it out in a sentence to explain it. I'm not going to make you write a sentence, but these 3 items right here that are starred are going to be what I expect, and this is what I will be grading on your test. All right, so to get a complete credit on a test, you must show steps 2, 3, and 4 on your paper, okay? All right, so let's see what to do. Attendance at a local church has been greatly diminished by COVID. The church has about 1,600 in attendance for their 2 services total. This was 2/3 the amount of a normal Sunday had it not been during the COVID pandemic. How many people would have been in attendance on a normal Sunday? Now, the word this right here refers back to that number. This number, okay, my cat is joining us here. Sit down. So this 1,600 was 2/3 the amount on a normal Sunday. Well, now, what are we looking for? We're trying to find the amount of attendance, or the people in attendance on a normal Sunday. So our answer is looking for people. Okay? If we want to use a variable that helps us represent people, then that would be fine, use a P. But here's what we would have to do. First of all, we have to write number 2 says write a let statement. So I'm going to let P equal to the number of people. And you can even use number symbol. You don't have to write it out so completely. Okay? So now I'm going to substitute in place of the word this, I'm going to substitute in the 1600. So I would say 1600. The word was means equals 2/3 the normal Sunday of the 2/3 of the amount of people. So the amount of people that would normally be there. So 1600 equals 2/3 P. Now this one's a fractional value. So what we do is we look for our common denominator. Common denominator would be 3 because that's the only denominator. So first of all, I'm going to multiply both sides by 3. Then on the right hand side, the 3's are going to cancel. Over here, I'm going to multiply. So that would be 4,800 equals 2P. Now I want to get P by itself. So I'm going to divide both sides by 2. So my answer comes out to be 2,400 equals P. So there are normally 2,400 people. Alright, so this problem that I just worked follows every one of these guidelines right here. Now, my expectations for you is that you label, we have to have a let statement, we have to write the equation, then we solve it, and then our answer. So our answer says this represents 2,400 people. So I just need that information as you work through the problem. Okay, the next problem is very similar. It says Southern Labs rents a computer terminal for $400 per month plus $8 per hour of computer use time. The bill for 1 year of computer use time was $7,680. How many hours did Southern Lab actually use the computer? Now, here's the thing you have to be careful for. This wants 1 year, but this is payment per month. Okay, you got to think about that. So what are they asking us to find? How many what? Hours. Okay, so we're going to let H equal the number of hours. Then we translate. Okay, they have $400 a month plus $8 per hour to use their time. So we've got $400 plus 8H, but that's only for 1 month. How many months do we have? 12. Okay, so that means we've got to multiply this times 12, and that will give us the cost of the bill, because that bill is a yearly cost, not a monthly cost. So now, this is a distributive property. So you multiply 12 times 400. Well, 12 times 4 would be 48. So that would be 4,800. And then plus 12 times 8 would be 96H equals 7680. Now solve for H. You want to get H by itself. So I'm going to subtract 4,800 on both sides. Okay, pull your calculator out. Pull your calculator out, and we're going to say 7680 minus 4800 comes out to be 2,000. So 96H equals 2,880. Now I'm going to divide both sides by 96. So while you've got it already on your calculator here at 2880, all you have to do is hit divide by 96, because that'll pull that number up. Divide by 96. So it says H is going to equal to 30. So what does 30 represent? 30 what? So your answer should say 30 hours, and that's what we're looking for. Okay, this is a problem that you kind of have to think about, because it doesn't say that $400 is a yearly payment. It says $400 is per month plus $8 per hour. Okay, so this problem's a little bit different. Now, you will see these next kind of problems, and these are really common problems for math problems. These are all related to geometry, and the only kind of problems you're going to work on right now are perimeter problems. What is perimeter? We talked about that the other day. That's the distance around something. Okay, some sort of object or some sort of shape. Now, first of all, right now, that tells us we can't get negative answers because distance can't be measured in negative. So you also have to recall some geometry formulas. And some of the homework on 1.5, I think 1.6 it was, you had to plug some numbers into formulas. Well, this is one formula that you should always know. Perimeter is made of 2 lengths and 2 widths. Now, for a triangle, you just simply add up all 3 sides because there's not really necessarily a formula for it. Now, here's the way I suggest to work a problem like this. Draw a reasonable representation of the figure that they're telling you about. Then choose a variable to represent what they don't tell you. Label the figure with the numbers and the information. So then we can work off of a picture. Solve the problem and then answer the question. So let's look and see. The length of a rectangular piece of steel in a bridge is 3 meters less than double the width. Alright, so I know I'm going to have a rectangular piece of steel, so I want to draw a shape that looks like a rectangle. Doesn't have to be big, but make sure that your figure looks like what they're telling you. Alright, the perimeter of the steel piece is 48 meters. Find the width and the length. Okay, so I've got to give 2 answers. Now, when I go back to the first sentence, there's something that they tell me. The length of the steel is. So they're telling me about the length, which means they're not telling me about the width. I don't know what the width is. So that's what my variable represents. So width is unknown. So I'm going to go on my figure and I'm going to let this and this represent my width. It's the same number because both sides are equal. Then I go back and I use the information that they told me so that I can figure out what to put up here and down here for the length. So it says the length is 3 meters less than double, okay? 3 meters less than, double means times 2. So I'm going to put 2 W's, double it. But then I have to take away, because it has to be getting smaller, by 3. So this is going to represent my length. Now I'm not going to write an L anywhere, but I'm going to write this value in the space where the length is. Okay, so you should have those representations. Now we could go up and use this formula at the top, but the basis for perimeter means we're just going to add up all the sides. So now look in the picture and collect like terms. How many W's do we have? Well, we have 2 here and 2 here, so that makes 4. Then we got 1, that's 5, and 1 over here makes 6. So make sure you count up all your W's correctly. So now I'm just going to write 6 W's. Okay, then I've got a -3 and a -3, so I lose $3 and lose 3 more means I've lost $6. And then up here it says the perimeter, so this distance all the way around here has to be 48 meters. Okay, now solve the problem, because I'm going to only get W for my answer because that's the only variable I have right now. So I'm going to add 6, so I get 6W equals 54, and I'm going to divide by 6, so W is going to equal to 9. And then now that I know what W is, I can go up here and I can plug it in and substitute at the value. You know what that's called? Evaluate. Okay, evaluate by plugging it in. So my L is going to be 2 times 9 minus 3. So 2 times 9 would be 18 minus 3. So L will equal 15. Now label your answer. What units is it given in? It's given in meters. So you can put an M on each one. That represents meters. So 9 meters is the width and 15 meters is the length. You have to answer both questions. And on your homework, it's going to have a problem that's exactly like this one. They just change the words a little bit. All right, the next one. A vacant city lot is being turned into a neighborhood garden. The design features a fenced triangular section of the lot for flowers. Okay, what kind of shape is it? It's a triangle. Okay, so I'm going to draw a triangle. Nothing fancy about it. The longest side of the triangle is 7 feet. Okay, longest side, 7 feet shorter than the shortest side. Okay, so they tell me about the longest side, but they don't tell me about the shortest side. So this one, I don't know anything about. The third side is 6 feet longer than the shortest side. So the only thing I don't know about is the shortest side. So pick a variable, and in this case, you can use X because we're just talking about measurements and there's nothing specific about the sides. So if I let the shortest side, so pick one, let's let X equal the shortest side. Okay, so I'm going to pick a side and call it the shortest. So that's my shortest side. Now, this one looks to be longer than that. So I'm going to let this one be the longest. Okay, and this one will be kind of the medium one. All right. So my longest side is 7 feet smaller, shorter, than twice the shortest. So twice the shortest would be 2x, and it's got to get a little bit smaller, so it'd be minus 7. Then that other side that's not got anything on it is 6 feet longer than the shortest side. So the shortest side is x. We got to get bigger by 6. So this will be x plus 6. So if you just label all your information on your picture, then you know how to put it in your equation. Because we need the perimeter, and then we want to find how long each side is. So my perimeter is going to be 59 feet. That means count up your x's. So I'm going to count them. That's 2, 3, 4 x's. And then I have a positive 6 and a negative 7. So a positive 6 and a negative 7 is going to give me negative 1. And that all has to add up to 59. Now just solve a simple equation. Add 1. So I get 4x equals 60. And divide by 4. So x is going to be 15. Okay, so 15 feet would be the shortest side. Okay, now I'm going to go back over here. So wherever I see an x, I'm going to evaluate. 15 plus 6. So the other side would be 21 feet, would be the third side. And then the last one, we'll call it the longest side. 2 times 15 would be 30. Minus 7 would be 23. So now we have all 3 sides of the triangle. So once you find 15, you got to go back up here and put it in for x. So evaluate to get the rest of the answers. And that's all you have to do on these. I think if you'll work at them, you're only going to have a few on the homework, but you've got to work at them. Don't just ignore it. I know you can do it. Bye.